All right, think of your geometry class, and we are going to draw a triangle.
I hate geometry so much.
All right, how many sides? We're going to talk about right triangles, right?
Where do you want us to draw them?
In a triangle, I want to name all the sides. First of all, we have a right angle. We're talking about right angle triangle. What do you call the side opposite the right angle?
Jason.
Hypotenuse.
Hypotenuse. This is the side opposite
Oh,
the
yeah,
right
yeah.
angle is the hypotenuse. Does everybody agree with that?
Yep.
Yes.
Okay, now, depending on the other two angles that we're talking about, so if I'm talking about this angle, which we're going to call theta, if I'm talking about this angle, we are going to name this side what and name this side what? Do you remember in geometry what we called these two sides?
Legs.
Say it again.
Legs.
Legs, okay.
Jason.
Adjacent, that's the words I'm looking
And
for.
opposite.
Adjacent, which would be which one? What does adjacent mean? Adjacent means
Next
next
to.
to. Adjacent means next
And
to.
then it's opposite.
Did I spell that right?
I think it's
I don't think so.
A before this.
Close enough.
Adjacent.
Oh, it's adjacent. Doesn't it look weird? Adjacent, adjacent, and then this side is gonna be opposite. So if I switched my angle that I was talking about and called this my angle theta, would this side still be the opposite?
No, adjacent would be.
This would be the adjacent and this would be the opposite,
Yeah,
right?
yeah.
That's important, you have to know that. Everyone understand that? Okay, now, you also learn,
Alan, you're an idiot.
What up now?
What are you two doing? Well, that was weird.
Travis is.
What?
okay, so, in
Oh, I thought you just stepped up.
In geometry, you learned about the sine, cosine, and tangent ratios. The sine, cosine, and tangent ratios are just comparisons of two sides, referring to the angle that you're talking about. So, the word sine, and now we're on our notes. The word sine is going to compare, does anyone remember?
No.
What two sides? Sine compares the side opposite
Over adjacent.
over the hypotenuse. Remember SOHCAHTOA?
Yeah.
Uh-huh. You learned SOHCAHTOA. So sine is going to compare the side opposite over the hypotenuse. Now, I have another definition, and I want to talk about that while we're here. I'm going to kill two birds with one stone. If I were to draw a triangle in quadrant 1, we always like to talk about quadrant 1 angles. So I have this angle in quadrant 1. And when we analyze, we're going to analyze all angles. We're going to go all the way around the circle. Just so you know, and I'll say it again, when we analyze any triangle, the angle that we talk about is always the angle with the x-axis. it's always this angle. We don't talk about this angle, or this angle, or this angle. So, if it's in any angle in quadrant 1, it's gonna be referred to this angle right here. If it's in quadrant 2, so if I were to draw a triangle in quadrant 2, it'll be this angle right here, okay? If it's in quadrant 3, so if I were to draw an angle in quadrant 3, it's this angle right here. And if it's in quadrant 4, it looks like a bow, it's this angle right here. So the angle that we always talk about is the angle that is created with what axes? What axes is the important axes that I need to talk about? The x-axes, okay? So I do not want you to be looking at drawing an angle here, or up here. I want you, we're gonna refer to this x-axis right here, this angle right here. So back to quadrant 1, back to my angle. Okay, so back to this angle. So regardless of what measurement this angle is, which we're gonna talk about in a second, how do you get to this point right here? So you're on the x and y axis, right? So if you start at the origin, what is this number of units called? How many units is it? It's called x units. How many units is this called? Y. Does everyone understand? So to get this point, you go x units over and y units up. Does everybody agree with that concept?
Yeah.
So x and y. Now this is gonna be our right angle. So we're gonna call this our hypotenuse. And our hypotenuse also has another name. It's called r, because it's on the unit circle. Remember that circle that we drew yesterday? Now our y value in reference to this theta has another name. Instead of it called y, what did we call it? Actually, Jack named it. What did Jack call this? The side?
Opposite?
Yep. So when you say opposite, it's the y value. You gotta remember this. This is all stuff that you need to see. The side adjacent is otherwise known as x. So when someone says, what is the sine of this angle? Well, you know that the sine is defined as, it's a comparison, it's a ratio of the side opposite over the hypotenuse. Or you could say it's the y value over the r value. You're gonna have a circle, and you may have an ordered pair here. And you're gonna be all over the place, all over the circle. You're gonna be in this quadrant. You're gonna be in this quadrant. You're gonna be in this quadrant. So is it important to know the y value and the r value? Yes. Some people like to use the sides, and some people like to use the ordered pair. They're both good. They're both good. So it's good to know both. Please understand that this, does that make sense? That this x value is the same as this number right here. This y value is the same as this. So if you went over 5 units and up 7, 5, let's say that we're 5, 7, this is 5, and this is 7. Okay, how could you figure out the hypotenuse? You could do a squared plus b squared equals c squared. Figure out what that is. So if I said, what's the sine of this angle here? Well, you have to know what this side is, 7 over whatever that is. It's a ratio. If I say, what's the cosine, you would do 5 over whatever that is. So let's finish off. This is stuff that you should know from your geometry class. So we said opposite, which is y over r. Go to cosine. What is cosine?
Opposite, or I'm sorry, adjacent over hypotenuse.
Good job. Adjacent over hypotenuse. What's another name for adjacent? X over r. And do you remember what tangent is?
Opposite over adjacent.
Yep. Which is y over x. Now, there are 3, did you learn in geometry the 3 reciprocal functions?
No.
No.
If you were to take the number 3/5, and if I asked you to say, what's the reciprocal of 3/5, what would you say?
5 over 3.
5 over 3.
Oh,
So
yeah, we
everything
did that.
You did this then?
Yeah, it's everything
Okay,
flipped.
the reciprocal of sine is cosecant.
We never learned, like,
You
it
never
was
learned
diff-
it?
it was like the sign with the negative symbol, like the -1 symbol,
Oh, that's inverse.
and that's what we did, was
Okay.
inverse.
Okay. The reciprocal one is flipping. You're flipping. So if I wanted to compare, instead of saying the side opposite to the hypotenuse, I could say, what's my hypotenuse to my opposite side? And that's the cosecant. So if I were to just flip, all I'm doing is flipping these 2 numbers here. And for cosine, the reciprocal is secant. This is gonna be hypotenuse over adjacent, or r over x. And the cotangent one is the reciprocal of tangent, which is adjacent over opposite, or x over y. So, what is sine, cosine, and tangent? It's just a comparison. Given a certain angle, you are comparing the sides. Any 30-degree triangle, the sides of any 30-degree or 45 or any 60-degree angle, the sides will be the same. The comparison of opposite to hypotenuse will be the same. So what I want to do is I want to look at those special triangles. And you guys said, this is so random, why do we have to know this? This is why. Now, I drew these triangles and they're not drawn to scale by any means. I made my 45, my 30, and my 60 all that look the same. They are, I just did it just so that you can write. Do you all understand that a 30 degrees, a 45, and they're not the same angle? So you understand the 30 should be more like this. That's your 30. Your 45 is right smack in the middle, like that. And your 60 would be more closer to the y-axis, like that, okay? I just made them all the same. So, I want to talk about, let's see how good your memory is. Your 45-degree angle. What's this measurement right here? Good. Do you remember what angle I'm talking about when I talk about my comparison? This angle right here with the x-axis. So, can you tell me the sides of these? What are these sides called? What are the dimensions?
What do you mean?
What do you mean?
Numerical dimensions.
This was from the other day.
Remember Tuesday? Yeah, the numbers. These are called the special triangles, 45, 45, I'll give you a hint, 1,
It's 1, 1, 2,
root 2,
1.
1, 1.
perfect,
2, 2.
1, 1, root 2. 1, 1, root 2. So now, if I say what's the sine of a 45, here's my 45. you gotta know, what does that word mean? That
Opposite
word means
over.
opposite over hypotenuse. So you are going to compare in any 45-degree triangle, your ratio will be a 1 to a √2 ratio. How about the cosine? What will that be? Adjacent to hypotenuse. And tangent means opposite over adjacent, 1 to 1. Now there's something else you should know. Does anyone know anything about when you have a radical in the denominator of a fraction?
You have to get it on top.
Yeah, people don't like radicals on the bottom, so they make you get rid of a radical when you see a radical in the bottom. It's called, anyone know what it's called? Rationalizing the denominator. Yeah, these answers are fine. These are fine. These are unrationalized. But you may see along the line them doing this, √2 over √2. To get rid of this, you have to multiply the top and the bottom by that to get rid of it. So you're going to see this answer more commonly as, when you have a 45, you're going to see √2 over 2. This is the same thing, √2 over 2. And this one is just, you're going to see 1. Because 1 over 1 is 1. Okay? Let's move to the 30s. We're going to do this for a couple days. So here's our 30-degree angle right here. If this is 30, what does this measure? Because this is 90. 60. Okay, we know. Let's hop into our special triangle mode. What are the measurements?
1, 2,
1,
2 square root.
2, and then
2. You guys got
Three.
this. Good. So, when I say what is the sine of a 30-degree angle, well, what does sine mean?
Opposite over
Opposite, we're going to compare the side opposite to the hypotenuse. It's a 1 to 2 ratio. It's a 50-50 ratio.
Will this be on our testimony?
You don't have a test tomorrow.
I mean,
Thank God.
What?
Thank
As
you.
long as we have custom.
yeah.
Yeah.
There's no test tomorrow.
Thank you.
No.
I was freaking out.
If I did, I'm sorry, there's no test tomorrow. Cosine of 30 is √3 over 2.
What was that even?
And tangent would be 1 over √3. Now again, this one has that ugly radical. So if we multiply the top and the bottom by √3 over √3, you have √3 over. Good job. And the 60.
It's the same thing.
It's the
Thanks,
same thing, but
The things are different spots.
yeah,
60.
this is gonna get the √3. This side's gonna get a 1, and this side's gonna get a 2. So when we say sine of 60, it's gonna be √3 over 2. When we do cosine, it's gonna be 1/2. And tangent, √3 over 1, which is nice because we don't have to rationalize that one. Questions? Okay, now, do you notice the angles, where the location of all the angles?
I have a question. The only thing I don't know is like these, the 1, 2, and the what, 3, and then 1.
You have to memorize those. You have to memorize those.
I just don't know how to put them. For which
You give me a great performance in the record, right, with it. I'll do,
Okay.
MMA.
All right, now, I want you to go to this page right here. This circle. Stare at it for a second. It is the unit circle, and it's broken up very nicely for us. How is it broken up? Do you see how it's broken up? How?
from the degree thingy that we did yesterday?
Yes, it has. Let's put all of our angles in here. What's this, where do we start?
360.
0 and 360. What are all the major axes called? The more you do this, the better I'm telling you, you'll get it. What's this angle right here called?
180.
180. What's this one?
90.
90. What's this one? 270, and then 360. Okay, now, halfway between 0 and 90 is this one right here. These four right here. What are these called?
45.
Those are the 45ers in each quadrant. Remember, you have quadrant 1, we have quadrant 2, 3, and 4. So this creates a 45-degree angle in quadrant 1. This angle is going to create a 45-degree angle in quadrant 2. This is going to create a 45-degree angle in quadrant 3 and 45 in quadrant 4. So can you name these angles right here?
30, 45, 50.
We have 45. We have 90. Add 45 to all these.
135.
135, 180, add 45 to that, you get
25.
225, add 45, add 45, 315, and add 45, okay? Now, let's do the 30s. If we add 30, 60, 90, we can finish the rest, right? 30, 60, we're adding 30. So 3, 6, 9, 150, 180, 210, 240, 270, what's this one?
300.
300, 330, and 360. Okay, now, this is where it gets tricky. Okay. If I ask you, gotta find my black pen. If I ask you, what is the sine, cosine, or tangent of a 150-degree angle? I already did. I did the 30, I did the 60, and I did the 45. But I now want to go past this quadrant. And I want to go into this territory, and then this territory, and then this territory. And eventually, I want to go into those crazy 790-degree angles. So what are you going to do? Well, you're going to use the special triangles. And you are going to go past, you're going to go into this territory. So I'm going to ask you, how would you figure out what the sine, cosine, and tangent of a 150-degree angle? Let's go to this angle right here. Well, let's draw 150 degrees. This is what you did yesterday for me. Here's 150 degrees, right here. Right? Here's 150. Does everyone agree? That's 150.
You want us to do this?
Yeah. There's 150, right? Where does my terminal side lie? In quadrant 2. Where did I say we are going to analyze the angle? You're going to create an angle with the x-axis. So can you tell me the angle? We're running out of time, the bell's probably going to ring, but what angle is this right here? If from here to here is 150, what angle is this?
30.
This is 30. So if this is my 30, this side is 1, this side is 2, and this side is going to be negative root 3. Why did I call this negative root 3? Because in quadrant 2, x is negative. So when I ask you what's the sine of 150 degrees, you're going to say 1/2. If I say what's the cosine of 150, you're going to say negative root 3 over 2. And if I say what's the tangent of 150, you're going to say 1 over negative root 3.
So the rest is
Try to
homework?
do these problems right here. See if you can understand, try them, and we're gonna continue on tomorrow.